This is Mrs. Butcher, and this video is on exponential growth compound interest. Now there is a formula for compound interest that we're going to give you. And that formula is A equals P times 1 plus R over N in parentheses raised to the NT power. Where A is your after amount, so your final amount, just like in the compound growth formula. P is your prior amount. I think P stands for principal, but I like to say after and prior just so I can remember. And that's just like in your exponential growth formula. That's your before amount or your prior amount. The little r is your rate. That's your interest rate in decimal form. The t is your time in years, and n is the number of times that your interest is compounded per year. So when you do these problems, you're going to read them, and it's going to say, this account pays such and such quarterly interest. Well, there's 4 quarters in a year, so your n would be 4. Or monthly interest, then your n would be 12 because there's 12 months in a year. Or daily interest, you would use 365. So just look at what the problem says, and that tells you what number you want to use for n, and it gets plugged in here and here. So an example of this would be, say you deposit $200 into an account that pays 3% monthly interest. How much will you have in 2 years? So you just take the equation and you figure out what each part is. So our after amount, that's what we don't know. Our prior amount, our principal, we start with $200. Our rate, they said was 3%, so 0.03. Monthly interest means that your n is going to be 12 because there are 12 months in a year. And t, your time, they asked about 2 years. So we're just going to plug in all those numbers and punch it into the calculator to get an answer. And I know that this is easily punched into the calculator without writing it down, but if you want full credit, if you mess things up, you need to write down. So I need to see A equals 200, parenthesis 1 plus 0.03 over 12 raised to the 12 times 2. So when you do this in the calculator, a lot of times it's easier to do this part first, right? And then add 1, and then say answer to the 24th power, and then multiply it all by 200. And when you do all that, you will get an answer of $212.35. So you started with $200, you end with $212.35. You've made $12.35 in 2 years, but you've done nothing with your money except leave it there. So that's okay. That's not a great rate of return, but it is what it is. So when you deposit your money into an account, they're not going to offer you great interest rates, and they're not going to offer you, very good compounding. Compounding means like they're going to charge you interest, or they're going to pay you interest, whatever, on your amount. And then a month later, they'll pay you interest on top of what's in there plus the interest that you've already earned. And so every time you've got a little bit more money, earning a little bit more interest. And so it's exponentially growing. But think about your credit cards. Your credit cards charge you interest. So how are they going to maximize the amount of interest that you pay them? The more often you compound it, the more interest you actually have to pay. So, monthly would pay more than quarterly, but daily would pay more than monthly. You could do it by the hour, you could do it by the minute, you could do it by the second. But the way to make a continuously compounded interest rate is to use this problem. We call it Pert in the math world because it's A equals PE to the RT power. And we'll give you that equation. Once again, A is your after amount, and P is your prior amount. E is the Euler number that we learned about yesterday, 2.718, etc., and just use the E button in your calculator. R is your interest rate in decimal form, and T is your time in years. Okay, so our next example is a credit card example. Say you're going to college, and let me tell you, when you get to college, the first week or so of school, there's booths everywhere set up all over campus and people trying to get you to sign up for magazines and clubs and join this and do that. And there's credit card companies and they've got free t-shirts and they say, you know, here's a t-shirt, just sign up for this credit card. So you do that and you're like, yeah, free money. And you go and you spend $1,000 on your brand new credit card, and this card has a 16% APR. Now, APR stands for annual percentage rate, but that's misleading because it doesn't mean that it's compounding it annually. They're compounding it continuously. So when you hear that APR, don't think, oh, once a year they're going to charge you 16%, because that's not how it works. So you spend this $1,000 and then your parents decide that, you know, they're going to give you some money for books and for tuition, and maybe you're on a meal plan, so they don't need to give you any more money, and you can't pay for it because you don't have a job. So if you pay nothing, not counting the late fees that they're going to charge you and charge you interest for, but we won't count that, what will you owe after 1 year? All right, so let's use the Pert equation. I did not mean to turn that green. There. Let's use the Pert equation. And we'll let A, our after amount, be what we're trying to find. P, our prior amount, is the $1,000. 1,000. R, your rate, is 16%, so 0.16. And T, your time, is just 1. So we're going to plug those numbers in. A equals 1,000. E raised to the 0.16 times 1, which is just 0.16. So you just punch that directly into your calculator, 1,000 times e to the 0.6 times 1, and you will get a grand total of $1,377.13. So after 1 year, you now owe them $377.13 more than you even spent. And that's because, you know, they loaned you that money and you haven't paid it back. And so they have the legal right to charge the interest on that. But that's how people get into credit card trouble. So there you go. There's your math lesson and your life lesson all put together in one. All right, you guys have a good night. I will see you tomorrow.